Okay, Assalamualaikum and very good morning to students taking Dynamics ECS 429. So for today's class, we're going to go back to topic 1, that is kinematics of particles. So today is 18th October 2021 and it's now 11:12 a.m. Okay, so we're going to go back to topic 1, kinematics of particles. Okay. So as you can remember, kinematics of particles is concerned with the geometric aspect motion of the particle, which is displacement, acceleration, velocity, and time. Okay, now, so for topic kinematics of particles, previously we have learned about the basic kinematic equation. There are three basic kinematic equation. What is it? Velocity equals to the time derivative of the displacement, okay, ds over dt. And then the second one is acceleration equals to dv over dt, okay. And the last one is ADS equals to VDV. Okay, and then we also have learned about basic kinematic equation, but is concerned with what? With constant acceleration. Do you remember the formula? The formula is V equals, what is the first formula? V equals to V naught plus ACT. The second one is S equals to S naught plus V naught T plus 1 over 2 ACT squared. And the third one is V squared equals to V naught squared plus 2AC and then S minus S naught. Okay, so those are the things. And today, what we're going to do is we're going to learn about the motion of several particles, more than one particle, relative motion. Okay, we're going to go into topic of relative motion. Okay, relative motion, motion of several particles. Okay. Now, all these three are related to rectilinear motion. You remember what does rectilinear motion means? You remember, guys? What is it?
Straight line.
Yes.
Straight line.
Moving in a straight line. Okay. All right. Okay. So now today we're going to start focus on motion of several particles. Just a little bit of a lecture first. Okay. Can you see my screen?
Yes.
Yeah.
Boleh, doktor.
Okay, all right, good. Okay, semua have their breakfast already or waiting to have brunch? Hmm? Okay,
Branch.
brunch, I see. Okay. All right. So, motion of several particles. Okay, so sometimes when dealing with rectilinear motions, we sometimes deal with motion of multiple particles, meaning more than one. Previously, you learned about a moving vehicle in a straight line. So that motion is involved only one particle. Now we are trying to understand and relate when there is a motion of more than one particle. Okay. So one way to simplify the analysis is to discuss the relative position of one particle with respect to another particle. So when several particles move independently along the same line, you can write dependent equations of motion of each particles. So the thing is that we must use the same origin there is 0 points of the coordinate system along the same time at t equals to 0. So dia punya syarat, the rules for motion of several particles, relative motion, it must have the same origin and it starts at the same time. So when we do that, we have this formula below here. So is the relative position B with respect to A. So X refers to position, V is velocity, and A is acceleration. So when you have a position B with respect to A, it is equal to XB minus XA. So if you want to find XB, it will equal to XA plus XB over A. And you know, when you differentiate the velocity, the position, you will get velocity. And if you differentiate velocity, you get acceleration. So you can use the same formula. Okay. So VB equals to VA plus XB over A, and AB equals to AA plus AB over A. Okay. So we can simplify the analysis of motion of several particles. So a good example is when you involve multiple cables and pulleys that are used by the crane. So you can see there is a pulley pulling the cranes together. This crane is pulling the pulley, is using the pulley to pull an object. So these are example motion of several particles. Okay, so let's go back to the screen. So what is the relative motion of several particles? Let's say we have two particles. Okay, hold on. So XB over A will equal to what? XB minus XA. So if you want to find XB, will be equals to what? XB over A plus XA. Okay. All right. And then if you want to find the velocity, it will be the same. Velocity will be VB over A plus VA. And if you want to find the velocity, the acceleration at B, it will be AB over A plus acceleration A. Okay, so those are the formula involves. Okay, all right. So let's just recap. So what we can understand is, kinematic is the study of the geometry of the motion. Okay, and then kinetics. What is kinetics? Do you remember kinetics? Kinetics is the study of forces that cause the motion. Okay, so that are two different things. So just let's kinematic is the study of the geometry of the motion. And if you remember for topic 2, what is topic 2 title? Kinetics of particles. And what is kinetics? Remember?
Relation between force,
Ah,
activity,
okay. So is a study, okay, of the forces, okay, that cause the motion. Okay, that is kinetics, yeah. Okay, and then what is rectilinear? Rectilinear is moving in a straight line. Okay, and then do you remember what is the average speed? Average speed is what? Is the those total distance traveled divided by what? The total time. You remember last week's class? Okay, class, do you remember last week's class?
Yes.
yes,
Okay, good. Okay, all right. And then if I say a particle is slowing down, what does it mean? Remember nyah pecut? What is nyah pecut in English? When a particle is slowing down?
deceleration,
Decelerate.
Yes, exactly. Very good. Decelerating. Okay, good. Okay. All right. Good. Okay. So that's good. Okay. So now maybe we can start to do a question that is related to example with constant acceleration. Okay. All right. Yeah. Okay. Hold on. Okay. Yeah. Okay. All right. Okay. Now, everybody has a pen and a book. Can you start copying this question in class? Boleh? Okay. Okay. Guys, are you copying the question?
Yes.
Yes, madam.
Okay. Can you tell me if you have finished copying?
Yeah.
Da. Okay, now let's start to do this question. Okay. Okay. During a test, a rocket travels upward at 75. Uh, okay, a rocket travels upward at 75 meter per second. Okay. and when it reaches 40 meter from the ground, its engines fail. So let's say we have a rocket here. Okay, let's draw a rocket. Okay. Okay. Okay, let's make the rocket blue color. Okay, maybe with some. Okay. Okay, so there's the rocket. So the rocket travels upward. So it's going up with a speed of 75 meter per second. Okay, and its height is 40 meters from the ground. So at 40 meters from the ground, and then all of a sudden what happens? Dia punya engine start to fail. So when engine is start to fail, what happens to the rocket? Dia akan start to drop down lah. Okay. So the engine starts to fail. Okay. So determine the maximum height SB reached by the rocket and its speed. So let's say this is point A and this is point B. So what it wants you to find is this maximum height. Okay, so what is one to find is this maximum height. So SB, okay, before it hits the ground. So at A is 40 meters. At B, what is the maximum height? And then all of a sudden, at C, dia reach the ground lah. At C, dia jatuh dekat the ground, okay? Alright. While in motion, the rocket is subjected to a constant downward acceleration. So what is the acceleration? So the acceleration A is negative 9.81. Remember, meter per second squared, eh? Wait. I want to write it here. Okay, acceleration is 9.8, negative, eh? Negative, eh? Don't forget, negative 9.81 meter per second squared. Okay. Now, due to gravity, so it's going down due to gravity. That's why there's a negative. Neglect the effect of air resistance. Okay, now the question is determine the maximum height it reached before it reached the ground. Okay, so when you see this question, of course, number one, it's a rectilinear motion because it's moving in a straight line. And for this question, which method you want to use to solve this question? Do you want to use the basic kinematic equation or the one with constant acceleration? Which one?
Constant acceleration.
Okay, why do you choose the one with constant acceleration? Why? Why, my dear?
Gravity.
Yes, okay. So, number one, what you do when you get this question, you write down back the basic question with constant acceleration, okay? So, we write back it down. Every time we get a question, we must write it down again and again, okay? So, V equals to V naught plus ACT, S equals to S naught plus V naught T plus 1 over 2 ACT squared, and then B squared equals to V naught squared plus 2AC, and then S minus S naught. Okay. Now, from this equation, you need to choose which equation you want to use to solve this problem. Okay, which one you want to use? Equation number 1, 2, or 3? Guys?
The first one?
The first one, okay. Why you want to use the first one? Because right now he asked to determine the maximum height, SB. In the first equation, is there SB formula?
No.
No. So which formula you want to use?
Number three.
Number 2. Okay, now let's say you
Number
choose
2.
number 2. Okay, number 2. Now, number 2, you have the symbol S and you have the symbol S naught. Okay, S and S naught. S is the final position and S naught is the initial position. You understand that? Okay, now, right now you have three positions, A, B, and C. It means for the equation number 2, you can relate A and B, B and C, A and C. You understand? You can relate any two position. But the first one, S will be the earlier position, and the second one, no, S naught will be the initial position. S naught will be what? S naught will be the initial position, and S will be the final position. So let's say we want to relate from SA to be the initial and SB to be the final. So you need to rewrite the formula to make it easier for you. So all you need to do is write SB to be the final equals to SA plus V naught T plus 1 over 2 ACT squared. Now, for V naught, what does it refer to? It refers to the initial position at A. Okay? All right. Because it means V naught, right? Initial, right? Okay. Do you understand, guys? Are you okay? Can we proceed? Any
Okay.
questions? Okay, now. Okay, let's write down the parameters that we have. Do you have SB?
No.
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 So the SB is what you want to find. Okay. Now, do you have SA?
Yes.
What is it?
40 meter.
40.
Okay, 40. Do you have the initial velocity at A?
Yes.
What is it?
Yes.
70 meter.
75.
75.
75. Okay. Do you have the time?
No.
Hmm? You do not have the time.
No.
Okay. Do you have the acceleration?
Yes.
What is
Negative
it?
9.81.
And do you have the time? No.
No.
Okay. So what do you think? You have two unknowns here, right?
Yes, formula 3.
You have two unknowns here, right? So it means it's not suitable for you to use equation number
2.
2. So do you think we should try equation number 3? Maybe we
Yes.
can reduce the number of unknowns?
Yes.
Okay, let's try equation number 3. Okay, do you get what I mean? Okay, it's okay. That's why we first try the second equation. So that I just wanted to show that if you use the second equation, you'll be left with two unknowns. So it's going to be difficult for you to solve. Let's try the third equation. So this one will be VB squared equals to VA squared plus 2AC SB minus SA. Okay, now let's put it into the formula. So what is VB squared? Now, when the rocket reaches the maximum height, what do you think the velocity will be?
Same.
Yes, 0. When it reaches the maximum height, the velocity will be 0. Okay, that is something that you need to know. So when it reaches the maximum height, the velocity will be 0. And what is the velocity at A? It is 75 plus 2 times 9. Don't forget the negative. What is the SB? Is something that we want to find. And what is SA? 40. Now, as you can see in this formula, number 3, you are left with only one unknown, right? So can you please try to solve and find me what is SB? What is the answer? Can you give me the answer quickly, please?
Cik Madam tengah buat.
Okay. Take as much time as you can. No, I need you to be quick, eh? Okay. What do you get?
Madam, saya dapat negatif 36, Madam.
Hah? Jangan lupa, 75 ni ada kuasa 2 tertinggal. Okay, kira balik. Maaf I makan buah orange. Okay, kira balik kan
326.7.
ramai dalam. Berapa?
326.7.
Okay, maksudnya 327 lah. Okay, betul? Betul?
Betul.
Okay, betul. Okay, good. That is the answer, yeah. Let's say I add another question. Find me velocity at C. Now, the velocity just right before it reaches the ground is not zero, eh? There is a value for it. So can you find me the velocity just right before it reaches the ground? Now, so when you want to find the velocity at C, you can use the same method, meaning you can use the same equation, but you can either consider, what I mean is, you can consider point C and A, or you can also consider point C and B to solve the problem, but you will get the same answer. You understand what I'm saying? For example, you want to consider point C and B. So it will be VC squared equals to VB squared plus 2AC SC minus SB. And you will get the same answer if you consider point C and point A. You understand, guys? And the velocity just right before it reaches the ground is not zero. There is a value to it. Okay, so how do you do it? What is VB? What is VB? What is the velocity at B?
0.
Yes, 0. Plus 2 AC negative 9.81. And what is SC?
0.
Yes,
0.
0. Minus 327 that you found just now. So what is the velocity at C? Can you tell me the answer?
80.
Berapa? 80.1. Betul ke? Meter per second. Okay, but is it positive or negative? Now, when the rocket was going up, you have assumed it to be positive, right? So when it's in the other direction, it should be negative. So you either give your answer 80.1 meter per second going downward, or you can give your answer to be negative 80.1 meters per second. And we will understand that it means it's going in the other direction. Okay? Both of these are the right answers. So if you want to consider the other formula, which is VC and which uses C and A, you can also do it, and you will get the same answer. Okay, so if you do this, you will get the same answer. Okay, as long you know what are the 2 points that you want to consider to solve the problem. Okay, Is everyone okay with this question? Are you okay, guys?
Yes, betul.
Boleh? Okay. All right. Now we're going to do another question. Motion that involves several particles. Are you ready?
Yes, betul.
Yes.
Boleh? Okay. All right. Okay. This one is in your textbooks, eh? This is sample. But do not look at the solution, eh? Let's do it together, eh? Okay, we do this together. We settle it together and don't use your textbook, eh? And don't open your textbook. Okay, ada somebody just entered our class? Okay, Ahmad Mustaqim, you are late. What is your reason? Mustaqim, why are you late? Okay, kenapa tak jawab? Tanya kawan-kawan.
Hello, Prof. Sorry.
Why? What happened?
Saya tidur, Prof. Sorry.
Okay, it's okay. We have this recorded video. Can you please promise me that after this class is finished, when I send the recorded video, maybe the end of the week lah selalunya kan, I will post in Evans the recorded video, or all you need to do is just view it. Boleh?
Okay, madam.
Okay, tell me when you finish copying the question. Done?
Done, madam.
Okay, now. Okay, are you okay, guys? Can we continue? Okay, right. Be
Boleh
quiet
doktor.
today. Okay. A ball is thrown vertically upwards from a 12-meter level in an elevator shaft. Okay, let's say kita ada satu elevator shaft ni. Okay, there is a ball which is thrown at a 12. Okay, elevator shaft ni panjangkan sikit lah. Okay, is thrown up in the air at the height of 12 meter. Okay, and then dia punya initial velocity adalah 18 meter per second. Okay, at the same instant ada satu open platform elevator. So ni adalah gambar open platform elevator that is passing at the height of 5 meters. Okay. And then it is moving upwards with a constant velocity. So ni pun ada constant velocity. Velocity dia adalah 2 meter per second lah. Okay, dia punya velocity adalah 2 meter per second. Okay, so ada dua this is the ball. This is the platform elevator. Okay. So what do you think happens later? The ball will land on the platform elevator, right? Okay. So as this goes up, and then at the same time, this platform elevator goes up, the ball will also go where? Also go down, right? And then at a certain point, what will happen?
Contact.
Yes, the ball will land on the elevator. Okay. Okay. Alright. So, okay, mungkin tak cantik nampak height dia macam lebih kurang Let me just adjust this diagram sikit. Nampak tak realistic sikit. Okay, just give me a second. Maybe sini kot. Ni. So the height will be up from here. Okay. Okay. So nanti it will go up and then it will go back down. Okay. And then the velocity ni adalah 18 meter per second. Okay. And then it will reach at the same level. Okay, now, so let's read back the question. Okay, do you understand? So just imagine ada satu platform elevator, dia tengah going up. At the same time, there is a ball that is dropping down. So at a certain time, they akan contact with each other. Yeah. Okay, that's good. Okay. All right. So we know that this is a rectilinear question, because it's moving in a straight line. And at the same time, we know that this question uses constant acceleration. Why? Because of the ball. Okay, all right, okay. Okay, because of the ball, because when it goes down, it is going down due to gravity, which is negative 9.8 now. 81, apa? Sorry, 81 meter per second squared. Okay, due to acceleration due to gravity. Okay, right. So the question is when and where. So in this question, it is asking when. Maksudnya asking the time. Okay, make it a bit cut sikit. All right. It is asking the when. When is the time and where? The position. Okay, when the ball will hit the elevator. So it wants this one. When the ball will hit the elevator. Okay. All right. So it wants this final position. And as you can see, when the ball hit the elevator will be the same position where the elevator will stop, right? So we can say that SB will equal to SE. Okay. Here I'm using the symbol B for ball and E for elevator. Okay. All right. Now, let's look at the parameters we have here. Okay, let's write it down to understand better. Okay, usually the parameter that is constant with the geometric adalah S, S, V and other and acceleration. Okay, let's write down the parameters we have. Okay, do you okay. However, you also have the initial position, right? Okay, so now let's write down for the ball. Okay, what is S naught of the ball?
12 meter.
12. Okay, what is SB of the ball? Do not know.
Unknown, sorry.
Okay, unknown. Okay. What is the velocity V naught? Sorry. What is the V naught of the ball? The initial velocity of the ball?
18 meter per second.
18 meter per second. Okay. All right. Now, what is the SB of the ball? You don't know. You don't know, and it didn't ask, but it's okay. Okay. So you do not know, eh? Do you know what is the SB of the ball? The final position of the ball, do you know that?
No.
No.
So you do not know. Okay, so you do not know. Okay. And do you have the acceleration of the ball?
Yes, 9.81.
Okay. You're forgetting one something in front.
Negative.
Okay. Okay. And also we do not have the time. But however, for this question, because it involves more than one particle, the origin is the same. The point here, the origin is the same, and the time it starts is also the same. Okay, that is the two condition that we need to have. So this is for the ball. Okay, now let's write the motion of the elevator. Okay. Do you have the initial position of the elevator? What is the
5 meter.
initial position of the
5
elevator?
meter.
Yes, good. 5 meters. Okay. Do you have the final position of the elevator?
No.
No. Do you have the initial velocity of the elevator?
Yes, 2 meter per second.
Do you have the initial velocity of the final velocity of the elevator?
No.
Okay, now try to read the question again. What is 2 meter per second? What is this? Constant velocity is 2 meter per second. What does it mean? It means the velocity is constant. So the initial and final velocity is the same. Okay? And what is the acceleration of the elevator?
Zero.
Yes, 0. Okay, good. Okay, now, so we have the motion of the ball, we have the motion of the elevator. Next is we need to decide which basic kinematic equation you want to use. So again, I will always advise my students to write down the basic kinematic equation again and again every time you answer the question. So what is the basic kinematic equation? V equals to, hold on. V equals
V
to
naught.
V naught plus ACT, and then you have S equals to S naught plus V naught T plus 1 over 2 ACT, and then you have what? V squared equals to V naught squared plus 2 AC S minus
S
S naught.
minus S
Oh,
naught.
yes, okay, good. Now, for this question, what we need to find? Go back. We need to find SB. Oops. Ahmad. Yeah. Yeah. We need to find SB and we need to find the time. But we know that SB equals to SE. This is something that we know. Now, so from this equation, this janganlah. Sorry. From this equation, which formula you want to use?
Second.
Second. Why you choose second? Why you choose second?
Entah saya tak pasti tapi saya rasa boleh kot.
Okay, alright. So dia nak choose second. Okay, let's choose second. Okay. So so let's choose second. Okay. Nak try, okay. Let him try to choose the second one. So S equals to S naught plus V naught T plus 1 over 2 ACT. Okay. So S will become what? S will be SB, right?
SB.
Okay, now what is our SB is what we want to find. Our S naught is 12. Our V naught is 18. Our time is what you want to find. And our acceleration is negative 9.81 and then T. Okay, now what can you see here? How many unknowns you have?
2.
So, macam mana? You'll be left with 2 unknowns, right? So,
Guna
when you
third
are
equation.
use what?
The third equation.
The third equation. Okay, you want to try the third equation.
Yep.
Okay. Okay, let's try the third equation pula. What is the third equation? What is the third equation?
V squared
Hmm.
equal to V naught squared plus 2 AC S minus S naught.
Okay, so this will be VB squared equals to V naught squared plus 2AC SB minus S naught. Okay, do you have VB squared?
No.
No, so you don't have this. So again, you'll be left with VB squared. V naught is
18.
sorry. V naught is 18 squared plus 2 negative 9.81 and then SB minus S naught is 12. Okay. Again, you're going to be left with
2 unknown.
2 unknown. So what do you think?
Use the first one.
First one. Okay.
Oh,
It's okay.
Use another equation.
Pardon? Yeah?
Simultaneous
Use the
equation.
another equation.
What is another equation?
Guna untuk elevation pula.
Elevation pula. Are you sure?
Use
Okay,
the
let's
first
try
one.
the equation for the elevation. Which one you want to try first? Okay, for that's why for this exercise I'm letting you think what to do. Okay, which one you want to do first?
Compare two equation boleh ke madam?
Yes, you can. What is the trick here?
Equation 2 and 3. Equation 2 and 3 boleh ke?
2 and 3. Nanti 2 and 3 ada 3 pula unknown. Satu SB, satu T, satu VB. No, that's not the
Yes.
solution.
Use third equation. Tapi guna elevation pula.
Use third equation lepas tu?
Lepas tu masukkan unknown for elevation. Lepas tu nanti kita compare ball punya equation dengan elevation punya equation.
Not really exactly. Let me give you a clue here. This one. SB equals to SE. Now think. When the final position of the elevator and the ball will be the same. So what do you think now? Can you think? SB
How,
equals to
madam?
SE. Give me. Tell me. Apa dia? Madam. Macam mana? Your main purpose here, you want to find SB and you want to find time. But SB is also equals to SE. Okay, now tell me, what do you want to do?
Kalau guna equation 3 tapi letak velocity 2 boleh madam?
You want to choose equation 3 and you want to put velocity 2 for what?
For
Motion of the
elevator.
ball or motion of the elevator?
Elevator.
Motion of the elevator. Okay, let's try. So you nak buat macam ni. VE squared equals to equals to not 18 equals to let me write down the equation first biar terang. So VE squared equals to V naught squared plus 2AC SE minus S naught. So VE squared berapa? 2. V naught squared 2 juga. Plus 2 9.81 SE apa?
5. S not.
S naught berapa?
5.
5. Okay, what did you get the answer? What is the answer, guys? Salah ni.
Acceleration
AC kosong. Salah ni. AC adalah kosong. So you tak dapat cari. Understand?
kena guna equation 2.
Tak boleh. Sorry guys, I tak perasan. AC adalah 0, so you cannot get the answer. So this method is wrong. Now go back to here. Go back to this clue. SB equals to SE.
Madam,
Hmm.
kalau cari T dulu kan?
Cari apa?
Cari T.
Cari T
Kalau
dulu.
Kalau
Hmm.
kita buat sebelah satu untuk elevator, satu ball. Dan kita dapat T kan?
Betul? Cari T dulu. Betul? So macam mana kita nak cari T dulu? Itu clue dia. So find T first. So how you going to find T first?
Guna equation 2.
Okay, guna equation 2 tapi untuk elevation pula. Betul tak?
Betul.
Okay. That's correct. So dia akan jadi SE S naught plus V naught T plus 1/2 ACT squared. So SE kita berapa? Tak cari. S naught kita 5 V naught kita 2, time kita tak tahu. And then this one dah jadi 0 kan? Okay. So SE kita adalah 5 tambah 2T. So do you notice? SE kita boleh jadikan sama dengan SE. Bila SE sama dengan SE, kita boleh cari apa guys?
T.
T. So you buat equation ball sebelah equation sama dengan equation elevator. Okay. So equation ball tu yang kat atas tu berapa? 12 campur 18 T campur setengah negatif 9.81 T square equals to berapa? 5 campur 2T. So dapatkanlah T. Lepas you dah dapat T, you boleh masukkan dekat equation salah satu daripada equation SB ni atau SE ni, you akan dapat jawapan yang sama. Okay, tolong carikan T dulu. Sorry saya makan buah orange sambil kelas ni. Tak apa
Tak apa.
Okay, dapatkan T. Dapat dah? Saya nak jawapan yang positif ya. Lamanya calculate. Dah lupa dah saya nak calculate.
3.65.
Betul? 3.65 berapa? Seconds Okay, that's the correct answer. So after that, you can put the answer T that you get 3.65 second into this equation or this equation and you can get SE. And you also can get SB. And you know that both of these answer are the same. Okay. Mama. Ya, pergi baring lah. Minum susu baring. Pergi susu minum baring. Mi. Okay. So please calculate for me what is SB or SE.
12.3.
Yes. So you get SB equals to 12.30 meters, which is the same as SE. Okay, good. So that is the answer. Okay, good. Now, can you do the next question? Okay, what is the next question? The relative velocity of the ball with respect to the elevator. So what you want here is the relative velocity of the ball with respect to the elevator. So it will be VB minus VE. Okay, guys, do you have the velocity of the ball? Guys, we're doing the next question. They're not the relative velocity of the ball with respect to the elevator. So you need to find VB minus VE. Do you have VB, guys?
No.
Okay, so if you do not have, do you think you can find it?
Boleh.
Using what?
Formula 1.
Okay, Formula 1 So Formula 1, V equals to V naught plus ACT. Now this will be VB equals to V naught plus ACT. So what is our VB? This is what you want to find. What is our V naught? Our V naught is 18. Our acceleration is negative 9.81. And what is the time? 3.65. So you can find VB. So what is VB?
Negative 17.81.
Okay, negative 17.81 meter per second. As you can see, it's negative because it's going down. Yeah. So what is VE? What is the velocity of the elevator?
2.
2, yes. 2 meter per second. So what is the relative velocity of the ball with respect to the elevator? Is VB minus VE. So VB is negative 17.81 minus VE, which is 2. So what do you get? The final answer?
19.81.
Okay, 19.81 meter per second. So that is the answer. Okay, guys? Boleh?
Boleh.
Boleh. Okay. Anybody has a problem in understanding this question? Okay. Don't worry, guys. It's actually fun to do questions that is related to dynamics, but you need a lot of practice. Okay. Once you try the questions, you will understand better. Okay, the variety types of question. However, if you do not try, it's going to be difficult for you. The more you try, the more fun you will feel, and the more easy it gets. But it will not be good if tomorrow is the exam, baru nak try. Tak boleh lah. You know, in Evans, there's already provided the tutorial questions. You can try those questions. Okay. All right. Okay, good. Now, so just to tell you, in topic kinematics of particles, okay, the type of questions, there are many multiple type of questions. Okay, number one, for example, involves a particle that is thrown in the air, for example, and then it falls down due to gravity with the acceleration of what? 9.81 meter per second squared. And then you can also have a question where you have a particle, for example, let's assume the particle is a car, for example. Okay, and this particle is moving at a straight line. Okay, and then it has a velocity, it has acceleration and position, and then time. For example, same as this ball. This ball also has a velocity, has a acceleration, has a position, has a time. Okay, but this one is a free fall. Okay, and this one, example, the car is moving uh, on top of a road, for example. Okay, and then you have another type of question. Okay, that can appear in topic dynamics. For example, you have a box. This box is being pulled by a pulley. Okay, let's say this pulley. This is a pulley, and then you have another box here. If box A is going downwards, box B is going to go upwards because the length is consistent. This is length A, this is length B. This one you call string, cord, string, cord. What else you call it? Rope, for example. And this is the pulley that is making it move. Okay, all right. So this is another type of question. So the length of the spring, the total length of the string will be LA plus LB. Okay, so this is another type of question that we sometimes need to be involved. And the total length of the string equals to LA plus LB. And this is the total length. Now, For this type of question, the length of the cable will be the same throughout. It will not extend. It will not be shortened, or it will be the same throughout. However, if you pull block A to the bottom, going downwards, the length of the string will be longer for LA, and the length of string LB will be shorter, but the total length will be the same throughout. Okay, do you understand what I'm trying to say there? Boleh? What I mean is, the length of the spring, tali spring tu sama. Tapi kalau you tarik blok A turun bawah, string LA tu jadi lagi panjang. Bila you tarik blok A turun bawah, blok B akan naik atas kan. Nanti string blok B tu akan jadi lagi pendek lah. Tapi tak kisahlah dia jadi panjang atau pendek. Total panjang string tu sama. Faham tak? Boleh guys?
Faham.
Okay. So bila you differentiate the total length of the spring yang constant, kalau you differentiate something that is constant, what will happen? If you differentiate, dia akan jadi zero. Tapi if you differentiate a string that changes length within time, dia akan jadi velocity. And then if you differentiate velocity, dia akan jadi acceleration.
Acceleration.
So what I'm trying to say is, there is another type of question that is involving that is involving apa, the length of the string, for example, that involves apa, several particles, for example A and B, that you need to understand to solve also. Okay, all right. Okay, so what I'm going to do today, I'm going to give you the question for you to copy, but we are going to solve it for our next class. But however, you can copy the question and you can try first if you can try to solve the problem. But however, what we'll do is, during our next class, we will solve the problem. Boleh?
Boleh.
Okay, all right. Okay, let's copy the question. Okay, but please do not look at the solution. Okay, all right. Copy first. Dah penat ke tangan? Are you okay, guys?
Okay.
Yes.
Okay, Doctor.
Okay, I'm a bit worried, because you're gonna have, do you have class at 2 o'clock?
Ada.
Yes.
Ada, kesiannya. Okay, tak apa. Copy dulu siap-siap. Nanti hari Khamis dah tak payah copy. Kita terus try to answer this question together. Boleh? Okay? Okay, untuk kelas saya subjek dynamics, you memang perlukan buku. So whatever you copy in this in your paper, I need you to transfer it in the book, proper book. Pergilah beli buku yang ada garis-garis tu. Okay? Dan janganlah campur semua subjek dalam satu buku tu. Okay? Kalau boleh, saya tak prefer you screenshot dekat phone. I nak you copy soalan tu.
Okay, Doctor.
Okay? Okay. Okay, soalan ni quite difficult so that's why you copy first. However, we will discuss in class, but at the same time you can try Okay. Collar A and block B are connected by a cable passing over pulley C, D, and E as shown. Pulley C and E are fixed while D is attached to a collar which is pulled downward with a constant velocity of 75 millimeter per second. At t equals to 0, collar A starts moving downward from position K with a constant acceleration and no initial velocity. Knowing that the velocity of collar A is 300 millimeter per second as it passes through point L, determine the change in elevation, the velocity, and the acceleration of block B when the collar A pass through L. Okay, now drawing the diagram. Make sure you all lukis jangan malas Ada ke yang screenshot dalam kelas ni? Lepas tu dalam hati cakap nantilah salin. Siapa tu? Ada ke?
Tak ada insyaAllah Doktor.
Tak ada, insyaAllah tak ada
Skill.
Jangan nakal-nakal Okay, maaf lukisan saya mungkin tak cantik sangatlah. Okay, tapi you all lukisan cantik, you all ada pembaris kan? Okay, it's okay if you don't understand how to do this because this is difficult. However, I will teach you how to do it on this Thursday, but copy it first. Okay? Okay. Okay. Tengah copy ke? Habis dah? Tengah lukis? So basically, this is an example of questions that involves independent motion of more than one particles. Okay, alright. But however, kita tadi dah try a question yang free fall kan, and then dia landed dekat elevator shaft tu kan. This one ada cables involved. Okay, alright. So we will try this question. Okay, it's difficult. However, when I explain to you this Thursday, you're gonna see, oh, it's not that difficult. Okay, but you have to wait until my explanation this Thursday. Hopefully, I don't want you to look at the solution because the solution is not going to be the same how I am going to explain it. Okay. All right. Have you finished copying?
Yes.
Dah. Okay, good. Can you please fill in today's attendance? Okay, so I will stop the recording. Okay. Before that, does anyone have any questions that they would like to ask?